In this video, I want to do a little bit more with analyzing a function using its first and second derivative, as well as talking about the extreme value theorem. First of all, to find the critical points, I need to know where the derivative is equal to 0 or undefined. So f prime of x, 3x squared minus 12x. Now, knowing I want to know where it's 0, I'm going to factor a 3x out. Leaves me with x minus 4. And again, I need to know what would make that 0. Well, x equals 0 and x equals 4 are my critical points. Next, I want to know where f is increasing. Well, to be increasing, I need the derivative f prime. I need to know where that's greater than 0. So let me do a little sign analysis here. Let me put 0 and 4 on a number line and do a little sign analysis of my derivative. If I plug in a number less than 0, 3 times that number is negative. That number minus 4 is negative. Negative times negative is positive. If I plug in a number between 0 and 4, 3 times that number is positive. That number minus 4 is negative. Positive times negative is negative. If I plug in a number bigger than 4, 3 times that number is positive. That number minus 4 is positive. Positive times positive is positive. Well, f is increasing when f prime is greater than 0, so that is from negative infinity to 0 and 4 to infinity. Inflection points. Well, inflection points occur when f double prime changes signs. Remember, it's not enough to say it's just equal to 0. It must change signs. So let me find the second derivative. F double prime 6x minus 12. Setting that equal to 0, x is going to have to be 2. Let me do a little sign analysis on that. Let me just put 2 right there. Let's do a little sign analysis of the second derivative. If I plug in a number less than 2, 6 times that number minus 12 is negative. If I plug in a number bigger than 2, 6 times that number minus 12 is positive. So the inflection point occurs at x equals 2. And remember, the only reason we can say that is because f double prime changed signs. If this had not occurred, if it went from negative to negative or positive to positive, this would not be an inflection point. It actually had to change signs. The interval where f of x is concave up, well, that's where f double prime is positive. We've already done the work for that. We know f double prime is positive from 2 to infinity. Finally, on the interval from negative 1 to 4, find the maximum and minimum values of the function. Here we are going to, and let me kind of block off some room here, we're going to invoke the extreme value theorem. The extreme value theorem says that if a function is defined at its endpoints, it must have a maximum and a minimum value. The best example I always can think of is a line. Okay, let me just draw that up here. If I have a linear function that goes on forever and ever, it doesn't have a maximum or a minimum because it goes towards negative infinity and infinity. However, if instead of going on forever, I define endpoints for it, and I say, no, it's at this spot and this spot, and it's just a line segment, well, now it has a maximum, and now it has a minimum, and that's the extreme value theorem. It says if you define endpoints for a function, if it's defined at those, it will absolutely have a maximum and a minimum. Well, here I have that. I've defined it as from negative 1 to 4. And if you'll remember from calc then, we need to check our critical points because these critical points up here could have been local maxes or minimums. but the endpoints could also be the max or min. And we call this checking the candidate test. Okay, candidate test, where we plug in, we have endpoints of x equals -1 and x equals 4. So we're going to plug those in the original function and see what we get. We're also going to check our critical points. Now you'll notice that one of the critical points is 4. So obviously I'd only need to check it once. Let me just kind of make a note down here that x equals 4, I don't need to check again. All right, but we should check all our critical points inside the interval and our endpoints. So let me start with the easy one. If I plug in 0 to my original function, 0 cubed minus 0 minus 2, I get y equals -2. Now you can use the calculator and you can plug in -1. If I do that, let's see here, -1 minus 6 is -7 minus 2 is -9. So y equals -9. Now I plug in 4. Well, 4 cubed is 64, minus 6 times 16, so 64 minus 96 is -32, minus 2 is -34. So my maximum value in this interval is -2. Okay, that's my max. I'm just going to draw a line to it. My minimum value is -34 on this interval. And that's extreme value theorem and the candidate test.